Hello and welcome to our next section in our congruent triangles unit. We're talking about the HL theorem and CPCTC. Ultimately, this is what we are trying to get to, the CPCTC. And HL theorem is our fifth way to prove triangles congruent, and you'll see what I mean in just a second. Now, it sounds weird that we have something called HL because everything up until this point has been has been angles and sides, but you'll quickly realize why we call it HL. Go ahead and get that title down in the index and in the table of contents. And then this title down, HL theorem and the CPCTC. So, HL theorem, and I'm going to actually call this RHL in parentheses, states that if a pair of hypotenuse and legs. Now remember, hypotenuse only occurs in right triangles, hypotenuse and legs. So it's a pair of them. Let me zoom out a little bit. And legs between two right triangles are congruent. Then the two triangles are congruent. Now, yes, if we're looking at this in a triangle perspective, we could still call them angles and sides, but it's more specific when we actually call them HL. Because in a right triangle, in any right triangle, the longest side is what we call the hypotenuse. So I'm going to draw a right angle here and a right angle here. It looks like it's right. I'm telling you it's right. And the side directly across that right angle is what we call the hypotenuse. And either one of these other two sides don't necessarily have to be congruent. We could call this first one leg 1 and leg 2. Okay. Now, if the case is we have, I'm going to erase this one for the 2 ticks, a pair of sides, specifically the hypotenuse and the legs, and a pair of legs. So I'm going to call this leg 1, or I'm just going to tick mark of that, right? It doesn't quite matter what this one is, because the moment we have a pair of hypotenuse and legs that are congruent, and I probably should tick that actually. Let's erase this one. So let's do this. Let's erase this, makes this red. So I'm going to call this one 2 ticks. Then I'm going to go and mark this one 2 ticks. So here we have a pair of hypotenuse that are congruent, and then the legs that are congruent. And we also have, these are in right triangles. This is why I call it RHL. And I'm going to call it RHL for right triangle or right angle, hypotenuse, and leg. So RHL. Okay. So if we have RHL happening, and if we name this, for instance, TCA and DOG, then we could definitively say that triangle, and I actually call this CAT, is congruent to triangle blank. Well, in this particular case, if we follow the order, C to A to T goes from the right angle to none through the hypotenuse. If we follow the same pattern, notice we're not going through the leg that's marked, so we have to start at O. Okay, then, we start at the right angle, then we go to O and then through the hypotenuse. So that's the order, G-O-D. And then this is going to be by, and we're going to call this RHL theorem. Now, most commonly in most textbooks, it will be called the HL theorem. I'm calling it RHL because I still want you to know there's 3 pieces of information we need to know. We need to know it's a right triangle. We need to know the hypotenuse are congruent and the legs are congruent. Now, the question then becomes, well, what if I have two right, ooh, let me do this in pink so you don't copy this out. Well, what if I have two right angles, right? And then they are both the legs are congruent. Well, these are still congruent. These triangles are still congruent, but not by RHL anymore. These are congruent by side angle side. So this one's specific to hypotenuse because you have the hypotenuse congruent. Okay? So there we have it. That's our fifth and final theorem to prove triangles are congruent. And that leads us always to this particular statement. CPCTC is is what we need to know from this. This particular statement tells us everything we need to know about our triangle because it tells us, oh, angle C is congruent to G, A is congruent to O, and D is congruent to T. Okay? And if you remember from when we talked about corresponding triangles, this stands for corresponding parts of congruent triangles are congruent. Now, this is a lot to say, and I'm going to make you write this out every single time because most people that write CPCTC don't actually know what this stands for. So I'm going to make you write this out every single time. And the idea is, if we needed to prove, for instance, normally we've been proving triangles are congruent. Okay? For instance, if I have ABC and then XYZ. And we don't know anything about this triangle besides, for instance, given, for instance, actually let's do all the givens. Angle, let's say AB is going to be congruent to XY. BC is going to be congruent to YZ. And then AC is going to be congruent to the last pair is XZ. We want to prove that angle A is going to be congruent to, and let me see if I get this order right, AB to XY, and then BC to YZ. I really should have done this in order, but that's okay. Angle A, let's mark this. Tick, tick. BC is congruent to YZ. And then 1, 2, 3. 1, 2, 3. Angle A would be congruent to angle X. Prove this statement. Well, we need to prove that these triangles are congruent first. So here we would write a two-column proof. So step 1 in a two-column proof. Prove that the triangles are congruent. And then step 2, use CPCTC to prove the proof statement. And in this particular case, since all of them are given, we could clearly see that A will be congruent to, angle A will be congruent to X because of where it's marked, or because of the side-side-side theorem postulate. So you could say technically triangle, if I said ABC, is congruent to triangle X, and this would go A to B to C, X, Y, Z. Oh, that was a complete accident. Then we could see A is congruent to X in this particular statement, okay? And that's what we're trying to do. We're trying to reprove that the triangles are congruent and then using that particular statement to show that corresponding parts are congruent, whether it's angles and sides or what have you, okay? All right, so that's what we have for today. We have now 5 ways to prove triangles are congruent, And now we have CPCTC that we use to prove corresponding parts of congruent triangles are congruent. If you do have any questions, please let me know, and I will see you in the next one. Bye.